Hi everyone, welcome to G World of Academic Physics. Today we'll discuss some more application of the electric field. In our previous lectures, we discussed about Gauss law and some of the applications for the uniformly charged distributions where some of the region like inside and outside we find the expression of electric field. Today we will consider the non-uniform sections. If the charges are non-uniformly distributed, how we'll find the expression of the electric field. Let me consider one example. This is a solid sphere of radius r, but charges are not uniformly distributed over the solid sphere. Here volume bound charge density is a function of r. Here rho is directly proportional to r square. Here rho naught is a constant. Now the question will ask you, find the expression of electric field in all the regions like inside and outside. Inside region, what is the expression of electric field? Outside region, what is the expression of electric field? When this kind of questions will given, two cases will be arise. When r greater than r means outside, and r less than r, this is inside region. We need to find the expression of electric field. It is pretty clear when you are looking for the inside region, we must enclosed within a Gaussian surface. This is my Gaussian sphere of radius r, because r is varying like this, and we must think about how much charge is enclosed within this region or within this surface of radius r. So I will write my basic Gauss law, that is E dot ds is nothing but q enclosed upon epsilon naught. This is my basic Gauss law that I am writing. Now you can think about it. EDS, if I will consider a very elementary section here, already in our previous lecture we discussed this thing, that electric field vector and area vector is mutually parallel to each other. So angle between them is 0 degree. So EDS can be written as EDS cos 0. So E is outside, this is nothing but ds, and we are looking for Q enclosed upon epsilon naught. ds is whose area? This is always fixed, that Gaussian surface area. So this is directly I can write integration is giving rise to 0 to 4 pi r square. So this will be fixed, that will get it 4 pi r square. I hope the student have no issue still up to this. And we will look now Q enclosed upon epsilon naught. What is Q enclosed? This is rho is uniformly varied, non-uniformly it is distributed. It is a function of r square. So what we will think about here, we can write this. First we will consider an elementary charge, how much enclosed. Then we will think about how much total charge has enclosed. This is the region. I am bringing this region to here. This is my region where the charge have enclosed. So I need to find how much charge is enclosed within this region. This is also a solid sphere. If I will go for the volume of the solid sphere, which is nothing but 4 by 3 pi r cube, how I am getting this volume of the solid sphere? This is nothing but volume of the sphere can be written as, this is nothing but V is directly, if I will write 4 by 3 pi r cube, but how you are getting these expressions? We are simply integrating 4 pi r square dr. Area into thickness, if I will go integration 0 to r, I will get this expression of the volume. This is area. It means a solid sphere can be break like a hollow, elementary hollow sphere of radius, certain radius r, and thickness is dr. Then I will do the integration from 0 to r, I will get the expressions like 4 by 3 pi r cube. If I will really find the expression of any volume of the sphere, what is the volume of the sphere? If I will think about the volume of the sphere, I know 4 by 3 pi r cube, but this how it is coming? Will simply area into thickness, because solid sphere is an element of hollow spheres. I will consider one element here, hollow sphere, one element, the area is 4 pi r square, and I say thickness is dr. That's why I'll get this kind of things. Similar fashion, I will, if I'll go for charge enclosed, this charge enclosed is nothing but integration of rho dv. This can be directly written like this. Rho is what is given, this is nothing but rho naught r square. dv is what, how this volume came, this is nothing but 4 pi r square dr. 4 pi r square dr. and I will integrate what? When the point is asking inside, we will only looking for this sphere. That's why the limit is 0 to r. So how much answer is coming? This is rho naught, this is 4 pi outside, this is r square we will get r4 dr, and limit is 0 to r. If I will proceed little quicker way, this is nothing but r5 upon 5. This is the amount of charge enclosed. I will simply substitute here. So this is E into 4 pi r square. Q enclosed can be written as 4 pi rho naught r5 upon 5. So these things have been cancelled out, and E you are getting rho naught rq upon 5 epsilon naught, rho naught rq upon 5 epsilon naught. This is probably the answer is coming in the inside region. I hope the scenario is pretty clear to everyone. One more time I want to explain these things is that I will consider a Gaussian sphere. I want how much charge is enclosed within this Gaussian sphere. I know the volume of the sphere is 4 by 3 pi r cube, but how this 4 by 3 pi r cube is coming? Because volume of the sphere, if I look about a sphere, if I consider a sphere of any radius r, how to find its volume 4 by 3 pi r cube? I will simply consider an elementary volume. This is my elementary volume. Then I will integrate this elementary volume. I will get the expression of this 4 by 3 pi r cube. Using the same concept here, I will write my elementary volume, and rho already given as per the term, it is non-uniformly distributed, and up to what extent my sphere is here, this is 0 to r because the radius of the sphere is 0 to r. Similar fashion, if I will go outside region, if I will go my outside region, this is pretty obvious that I will write my Gauss law. This is q enclosed upon epsilon naught. EDS angle is 0 degree because parallel to each other. EDS and DS is what? Gaussian surface area. I will simply write my E into 4 pi r square. This is obvious. Q enclosed can be written as what? Integration of rho dV upon epsilon naught. But here, if I will consider outside, this is my Gaussian sphere, this is my original sphere of radius r, and I will consider the point is outside. So I will consider the Gaussian sphere here, and the radius of the Gaussian sphere is r. That's why the area of the ds is whose area? Gaussian surface area. I will simply substitute these things. Rho dV. I will consider how much charge is enclosed within this Gaussian surface. This is my Gaussian surface. How much charge is enclosed? This region charge has enclosed within the Gaussian surface. Because this is my original sphere, this is my Gaussian surface. How much charge is enclosed? This section charge has enclosed. So limit is 0 to r. Similar fashion, what I am done here, I will do here. This is nothing but rho is rho naught r square. dV can be written as what? 4 pi r square dr. 4 pi r square dr upon epsilon naught. This is 0 to capital R. I hope the scenario is pretty clear. This is E into 4 pi r square. The LHS side is nothing but this is 4 pi rho naught r square is nothing but r4 dr. This can be written as, if I do integration, this is r5 upon 5 epsilon naught. So little cancel out the things. What is the expression is coming? The expression is coming rho naught r5 upon 5 r square epsilon naught. I hope the scenario is pretty clear. In two regions, we can easily find the expression of electric field in the two regions. Similar fashion, if I will draw one more example, I will consider suppose rho as a function of rho naught r. Rho is a function of rho naught r, any kind of question, rho naught upon r, that is rho is inversely proportional to r, and rho is not is a constant. Similar fashion, how many regions the question is asking? Two regions, inside and outside. If I will go inside region, suddenly a student can strike in the mind that E dot ds is nothing but q enclosed upon epsilon naught. E ds angle is always parallel to 0 degree because they both are parallel to each other, and ds is whose area? Gaussian surface area. So what is the area of the Gaussian surface? That is 4 pi r square, because two regions we are looking, r greater than r less than r. Here r is less than r because inside region we are looking for. So E into 4 pi r square. This Q enclosed can be written as what? Rho dV integrations epsilon naught. If you observe these things, this is my original sphere of radius r. I want within this region, what is the expression of electric field? This is small r. And how it is varies? That rho is inversely proportional to rho naught upon r. It means rho equals to some constant upon r inversely proportional to r. So I will simply substitute 4 pi r square. I will substitute rho value is rho naught upon r. dV is what? The elementary volume I will consider. This is nothing but 4 pi r square dr. Integrations, but integration is whose limit I will consider? Because I want charge enclosed within this region, so I will consider 0 to r upon epsilon naught. This is pretty easier. One can, this 4 pi has cancelled, and this is rho naught. 1 r has cancelled. So what is the answer is coming? So r square by 2. So 1 r square has cancelled. So rho naught upon 2 epsilon naught. This is the result is coming in this case. I hope this section is pretty clear. Please student look at the calculations. This r1 has cancelled. So this is nothing but r dr. R dr integration is nothing but r square upon 2. This r square finally cancel out. Only 2 epsilon naught. These are the expressions have been pretty clear. This inside region. If I will go for the outside region, similar fashion I will move. This is E into 4 pi r square. But what is the limit? 0 to capital R, rho naught upon r, 4 pi r square dr upon epsilon naught. Why? Because this is my original sphere of radius r. I want a point is outside, and how much charge is enclosed within this Gaussian surface. This is within this Gaussian surface, how much charge has enclosed? This is the amount of charge has enclosed, because this is my original, and this much of charge is enclosed. So maximum limit is what? 0 to capital R. That's why 0 to capital R. And similar fashion, if you solve it, you will reach to a conclusion that this is the expression of electric field. I hope this scenario is pretty clear. When this kind of question is asking in case of solid sphere, where charge enclosed is asking, suddenly it must be in your mind that integration of rho dV, whatever the value of rho is given, you just substitute there, and dV is what area? Elementary. dV is what volume? Elementary volume. So I must look into the elementary volume, that is 4 pi r square dr, and depending upon, if the point is inside, we will look into the Gaussian surface. If the point is outside, we will look into up to the body, we can find the limit. This is pretty clear in just in your mind. If the point is inside, we will look up to the Gaussian surface. If the point is outside, we will look into the original body. We are always looking into the original body. I hope the scenario is pretty clear to everyone. Those are looking these things, I hope it is benefit to them. Now we will go for the cylinder case. Look at, I will consider one example for the cylinder. Suppose this is a cylinder and the radius of the cylinder is r. How to approach the cylinder question? The radius of the cylinder is r. The question is asking that rho, this is a solid cylinder, and the volume bound charge density varying like rho equals to kr, where k is any constant. It means rho varies as kr, it means rho is directly proportional to r, like this is question is given. The question is asking find the electric field in all the regions, means inside and outside regions, r less than r inside region and r greater than r, which region? That is outside region. I hope this scenario is pretty clear to everyone. Similar fashion we will move it. We will consider which region? Inside region. Suppose this is my inside region. It means there will be a Gaussian cylinder will be here. This is my Gaussian cylinder inside region. This is pretty clear, you have to be in your mind. And this Gaussian cylinder, I want how much charge has enclosed within this Gaussian cylinder, and it is non-uniformly distributed. That's why we look into how much charge has enclosed within this Gaussian cylinder. So I will simply write my Gauss law, that is E dot ds is nothing but q enclosed upon epsilon naught. Here if you observe carefully, how many faces, how many surfaces? one is flat surfaces, another one is curved surfaces. If someone will observe very carefully, for the flat surfaces the area vector will be like this, mutually always perpendicular to the plane, but the field lines will be like this. The field lines will be everywhere, it will be like this inside the cylinders. So it is mutually perpendicular to the area vectors. Little better view if I want to provide, this is my electric fields, always will be like this. Inside just the top view of the cylinder, if you someone will observe top view, and area vector is like this. So area vector and field lines are mutually perpendicular to each other. So this EDS is due to what? E dot ds curve plus E dot ds flat is nothing but what? Q enclosed upon epsilon naught. This E dot ds flat is 0 because they are mutually perpendicular, electric field and area vector perpendicular to each other. We will only look for the curve one. This is obvious thing, so many questions on Gauss law we have already solved, so this student can easily predict these things. E dot ds, and angle is electric field and area vector. If I'll consider elementary area is outside like this small section, and electric field also like this, they are mutually parallel to each other. So electric field and the area vector are mutually parallel to each other, angle between them is 0 degree. So I will simply write EDS cos 0 can be written as EDS. This is integration, and this is Q enclosed upon epsilon naught. DS is whose area? Gaussian surface area. I will consider the height of the cylinder as L. If I will consider the height of the cylinder as L, I will put the Gaussian surface area. The radius of the cylinder is R, length is L. So what is the area? Perimeter into length. Perimeter, this is 2 pi r into L. This is my Gaussian surface area. And how much charge is enclosed? Similar fashion, I will rho dV epsilon naught. This is my basic concept. Rho dV epsilon naught. If I will consider a cylinder, what is the volume of the cylinder? The volume of the, if I will consider a cylinder of radius R and length is L, what is the volume of the cylinder? The volume of the cylinder is pi r square into L. And how this result is coming? You will consider an elementary hollow cylinder whose radius is R and whose thickness is dr. This is a way we can think about volume. When someone will solving this volume, have to think about the total volume is 4 pi r square L, but this solid cylinder is a combination of hollow cylinder. So I will consider an elementary hollow cylinder whose thickness is dr and whose radius is r, and simply if I will integrate 2 pi r sorry, if I will integrate if I want to get what? Pi r square L. How to get? I will get pi r square L. I want to integrate, and integrate is what? Area into thickness. What is the area? This is perimeter length 2 pi r dr, perimeter length into these things. I will get what? My expressions of total volume. If I will consider dV, dV is nothing but what? 2 pi r dr, perimeter into thickness, this is area, and length is always fixed, that is a fixed length, and I will simply integrate 0 to capital R. If you will observe very carefully, this is 2 pi and this will give you r square upon 2, and this is L, and this is capital R square. If I will put the limit, I will get the expression what? Pi r square L. I hope this how it is coming, every student pretty clear that how this area, this volume is coming, because I will consider an elementary hollow cylinder whose thickness is dr and radius is r. I will write my elementary volume for this hollow cylinder. Hollow cylinder, it can be written as what? Length into thickness into height. Length, 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 giving rise to what? Volume. So I will go for perimeter length into thickness into height of the cylinder. I will simply get what? And I will go for limit 0 to capital R, because how this dr is varying, it is varying from 0 to R. In this way I will get the expression. So similarly, where it is rho dV is given, I will simply substitute rho is already given at what? Kr. At dv what I will substitute? This is nothing but 2 pi r dr 2 pi r dr into L. This is the way I have to solve these questions. And what I'll go for, and this is epsilon, and what is the limit? Because I have considered my Gaussian surface is these things, so only this sections we will look into. So my limit is 0 to r. I already said if the point is inside up to the Gaussian surface, if the point is outside up to the body. So this is E into 2 pi RL. This is 2 pi L, 2 pi L automatically cancel. This is E. This is K, and this is r square dr. This is r square dr. This is epsilon naught. Integration limit is 0 to r, and 1 r is also here. So E r, this is nothing but K r q upon 3 epsilon naught. 1 r is cancelled. So what is the expression is coming? K equals to K r square upon 3 epsilon naught. So this is the scenario if a cylinder case is asking. The student must have to be very clear. If a sphere case is asking, rho, I'll simply 4 pi r square dr I'll write. If the cylinder case is asking, well, simply rho 2 pi r dr and height of the cylinder L. And whatever the point, if the point is inside, up to the Gaussian surface. If the point is outside, up to the body. This is the things a student has to be pretty aware about this scenario. If I will go for outside region, similarly directly I will bring to here this limelight, directly I will put it here. So E into what? 2 pi r, this is E outside region we are looking. E into 2 pi r L, this is what? Gaussian surface. And I will write simply what? Rho dv upon epsilon, this is my integrations. E into what? 2 pi rl. And I already know the limit is 0 to r, because this is pretty clear. This is my original cylinder, and I have taken the Gaussian cylinder is outside, and I want to know how much charge is enclosed within this Gaussian cylinder, and this amount of charge has enclosed within this Gaussian cylinder. This amount of charge has enclosed within this Gaussian cylinder. So my cylinder original is what? 0 to capital R. I hope this one is clear. I will put it this value of rho, this is Kr, and what is dv? I already mentioned here, 2 pi r dr into L. 2 pi r dr into L, and this is 0 to r upon what? Epsilon naught. So similarly E into 2 pi rl, little cancel, this 2 pi L always cancel. So E into r, this L already cancel, is nothing but what? K, this is 2 is here. 2 already cancel these things also. K, this is r dr, this is r square dr integration 0 to r upon epsilon naught. So similar fashion, if I will r, this is K, this is r q upon 3 epsilon naught. If I will put the limits, all these things, solving these things, so E equals to K r q upon 3 epsilon naught r. This is outside region. I hope this scenario is pretty clear to everyone. I hope those who have been watching, they can easily visualize what I am trying to do. So let me summarize for the student perspectives how if a solid sphere and hollow sphere, solid spheres and solid cylinders where rho is uniformly varying, non-uniformly varying, some k, any function of rho is a function of any r positions, you can say. If I will think about like this kind of scenario is giving to you, if it is a sphere, a student must directly think like E 4 pi r square and integration of rho dv. In case of a solid sphere, this is 4 pi r square dr, and in case of cylinder, we will write the cylindrical area, that is E into 2 pi rl. This is my rho, and this is 2 pi r dr L. If the point is inside, I will think about the limit is 0 to r. If the point is outside, I will think about the limit is 0 to capital R. If the point is inside, I will think about limit 0 to r. If the point is outside, we will think up to the body. A body means whatever the radius of the body, we will think about it. If this is a fundamental thing, if a student concluded in the mind any kind of questions on uniform, non-uniform cases on solid sphere and hollow sphere, solid spheres and solid cylinders can easily be acquired these things. I want to do one more questions so that student can aware that this kind of questions are also be framing. Look at the questions, how the questions has done here. This is my y axis, this is x axis, and this is z axis. This is one plane like this. A region between yz plane, this is one plane, this is a region, you can say yz plane, and there is another plane parallel to yz. If this is one plane, there is a plane another parallel to yz. Yes, so I will draw exactly another plane which is parallel to yz. And the distance between these two planes, I consider this distance between the two planes is nothing but d. The distance between the two planes is d, and in between, if charges have been there, suppose in between what is happening, charges is there, charges between them is there, a region between yz plane and another plane which is parallel to yz at x equals to d, at x equals to d. The charge density varies with x. The charge density, how it is varying with x, that is nothing but rho naught x square. The question will ask you, find the expression of electric field at PL0. This is the end of question is asking. One more time I want to repeat this question in a better fashion. This is what is given. This is my axes have been given like this. One more time we will think about it. This is z axis, this is x axis like this. This is kind of one plane. Exactly one parallel plane is here. Parallel plane means this is one plane exactly parallel to yz plane. It means I will draw one plane is here. This is exactly parallel like this. And this duri is given what? This distance is given what? You can think like d. This distance, this is one seat, this is another seat, and in between them distance is d. And what is given? In between them, if charge is there, some charge density exists, and this charge density between the two parallel seats, and it is varies how? That rho equals to rho naught x square. Find the expression of electric field at the point P, which is at position L0. This is position of what? L0. This is pretty obvious, and question is asking x varies from the origin. How this x is varying? X is varying from the origin. This is nothing but rho equals to rho naught x square. If I will only consider the side view rather than looking this kind of things, which is little confusing to our students, I will think like this is nothing but this view, just bring it this view like this. This view, just bring it like this. You can see this is kind of thick sheet. This is kind of what? Thick sheet like this, and here like this. In these sections we are looking only. In this section what is happening? This is my x, this is my y, and this is my z, and this is the distance is d, and this is my origin. This, can anyone think like this? This is a thick sheet. Yes, you can easily predict like this. This is a thick sheet. In our previous lecture we already think about that how to find the expression of electric field for a thick sheet, and the expression was rho d upon 2 epsilon naught outside and rho x upon epsilon naught inside. These are the things already we have done in our previous lecture. Please go through this previous lecture. Fundamentally it will help you. Here see carefully. This is rho equals to rho naught x square. This is non-uniformly distributed. So what I will consider, I know this point is here, L0. This point is here. This point P, they are asking the questions what? Find the expression of electric field. I know this point is here, and outside I know the expression is what? Electric field expression is rho d upon 2 epsilon. This is the expression outside I know. But Problem here is what? This is a varying thing, non-uniform cases. Rather than non-uniform cases directly go to these expressions, I will consider one element. From x to dx, I will consider one element. For this small elementary length dx, can I write my expression of electric field? Yes, the expression of electric field is dE, and dE can be written as rho dx upon 2 epsilon naught. Because when the width is d, we are directly writing rho d upon 2 epsilon naught for the point P. If it is a non-uniform case, I must look into what? I must look into that this is rho d upon 2 epsilon naught, and this is nothing but what? This is dE. If I will go for net electric field, I will integrate this dE. So this is nothing but integration of what? Rho dx upon 2 epsilon naught integrations, and integration limit is what? If the point is outside, we will integrate up to the body. So this is 0 to d. Thus this is pretty clear. So E is nothing but rho value is given rho naught x square. I will put dx upon what? 2 epsilon naught. I will integrate what? 0 to d. So if I will proceed in similar fashion, I will get rho naught x square integration is what? X cube upon 3, and this is 2 epsilon naught, and limit is what? 0 to d. So my result is coming, E is nothing but rho naught upon 6 epsilon naught dq. I hope this question is pretty clear to everyone. I hope this question a student can think about it like this. They have given the question, one more time I want to discuss. This is one sheet. Exactly parallel to YZ plane there will be another sheet. In between the two regions, charges have been present, and how this charge varies. Volume bound charge density varies like rho naught x square. The question is asking outside region, what is the expression of electric field? Just bringing the top view, I can easily consider this is like a thick sheet. I know the expression of electric field outside of the thick sheet is nothing but rho d upon 2 epsilon naught. But here the field is not uniform. I must look into for element. Where the non-uniform cases have been out, we must think about an element. So I just consider one element. From x to dx, I consider one element. And question already asking that from origin how it is varying. So I will write my dE, because for this small dx, I will write my dE. And I will putting the value of rho, which is nothing but rho naught x square. Here rho naught is a constant. Please keep it in your mind. Dx, and I will simply integrate. And what is the limit of integrations? If the point is outside, is up to the body, I just simply substitute the body limit, and I will get the expression rho naught dq upon 6 epsilon naught. I hope this scenario is pretty clear to everyone. So if any kind of questions is coming for solid sphere and hollow solid spheres and solid cylinder, please go through like this and like this. If this kind of questions also given, you have to think about some basic ways. These are the fundamental questions. Based on that, so many questions can be framed. I hope the scenario is pretty clear to everyone. I hope you guys will understood, and those who have been liking these things, please give your comments, and possible to share with your friends too, so that it can little benefit to others also. If any kind of things have been doubt also, you can put it here based on this Gauss law, all these things. I'll try my best to solve these things also. Thank you everyone. Thank you for your watching.